Hi everyone, my name is Fizana Amira binti Ramsey, and today I'll be presenting about introduction for this case study of Kerepek Kassah, banana chips. Okay, let's start. For this case study, early surveys and case study were referenced from the report of Perniagaan Kerepek Kassah. This factory in Sri Medan, Batu Pahat, Johor mostly sells banana chips, as well as the opening hours of 8 a.m. to 5 p.m. and this case study is responsible for making improvement by utilizing any tools that have been learned in the industrial engineering course. So the whole process of the banana chips production line is as shown as the figure above. The banana chips production line will be starting with unloading the banana from the truck, and then it will be sorted into the two types of banana that will be used. So after the sorting process, there will be the process of peeling the banana. Okay, the next, the peeled banana will be sliced into banana chips by slicing machine, and then the sliced banana will be fried according to the type. So subsequently, the fried banana chips will be de-oiled in order to remove extra oil. So from the banana, which bananas, which can help to extend the shelf life of the food. And after the oiling process, the banana chips will be added with flavor to give some delicious taste on it. So after that, the banana chips will be packed and labeled. That's all. So in this case study, the improvement tools that will be used is by using line balancing. So line balancing is a highly successful technique for increasing the throughput of assembled line and work cell while decreasing the labor expense and needs. So the next one is a problem statement. So problem statement is that the current layout that they are employing is not the most optimal configuration that we yield to the finest result. So the workstation cycle time is excessively long due to the station location. So next is the work location. Okay, this may have an effect on the amount of the labor required in the manufacturing process. And lastly, fresh layout design must be proposed for the company in order to enhance their working flow procedure. So the next one is the objective of this study. So the objective of this study is to gain an understanding of the banana chips manufacturing process, to propose a way to improve the current layout of the facility, and to use and utilize any tools that have been learned in the industrial engineering courses and implemented it into this project of case study. So and next one is to observe and analyze any issues that has happened in the industry, and lastly, to improve line efficiency through the use of line balancing. Next part is the project scope. So the project scope is which is to evaluate the operation, to study their manufacturing line for the manufacture of banana chips, and lastly, in accordance with the layout that has been seen and examined, it will concentrate on assembly line efficiency, and line efficiency will be improved through the line balancing process.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afam bin Lutfi Amir, and my matric number is DD190024, and today I would like to present about the literature review for this group project. Okay, first of all, a production line is usually linked to a continuous outflow manufacturing system. Production lines are beneficial for high volume activities. Work on a manufacturing line is split into specific jobs and allocated sequential along the line. The workload between different machine or workstations should be balanced in mass manufacturing on a progressive assembly line. When considering that the output to be obtained from the line is defined by the maximum time involved in working at one specific workstation, the necessity for line balancing becomes apparent. When one workstation holds up the overall production rate, the imbalance in the line wastes time at the other workstation. As a result, the cycle duration at each workstation must be level or balanced. Furthermore, line balancing is a valuable technique in manufacturing. The goal of line balancing is to make production line flexible enough to absorb external and internal inconsistency. This technique entails establishing a planned production rate for the material that must be manufactured within a specific time frame. Moreover, Proper line balancing necessitates ensuring that each line segment production quota can be reached within the time frame allotted utilizing the available production capacity. A variety of terminology is used in the assembly line balancing system. Each has its significant purpose. The cycle time, which may be defined as the maximum amount of time permitted at each station, is the first consideration. This may be calculated by dividing the necessary unit by the amount of manufacturing time available every day. This is the period in minutes between two goods leaving the production line at the same time. It is a precise indication that indicates how the line is now configured to execute it. For the methodology part, one industrial engineering approach will be utilized, which is the line balancing. Line balancing is a manufacturing technique that includes balancing the time and each machines to be balanced production to task time. It is designed to accomplish the necessary output rate with the smallest of the workstation. There are several benefits of line balancing, such as it may decrease weighting of waste, reduce inventory waste, absorb internal and external abnormalities. Besides, line balancing also may cut manufacturing expense and enhance revenues. Moreover, to implement line balancing, few calculation and steps needs to be done. The steps for calculating this case study are: first, collect all the data of the banana chips manufacturing process. The manufacturing process must begin with the unloading of the banana chips and end with the storage of the banana chips. Secondly, make a precedence diagram to demonstrate the link between those items. Thirdly, calculate the workstation cycle time, which is the maximum amount of time spent at the each workstation. Then, we need to calculate the theoretical minimum number of workstation and the line efficiency. After that, create an assembly line balancing table. And lastly, calculate the idle time for this case study.
Assalamualaikum warahmatullahi wabarakatuh. I am Ain Shakila and I will be explaining the result and analysis section. First and foremost, in this case study, the line balancing method is being utilized to increase the productivity of banana chips production. This is done by reaching the necessary output rate with the fewest number of workstations. Few processes will take place in order to produce the banana chips. Processes such as unloading, peeling, slicing, frying, deoiling, flavoring, labeling, and also storing will take place. This table contains the data for each related steps in producing the banana chips. Hence, a process precedence diagram is being created as shown in the diagram. With the output rate of 300 bags per day and operating time of 8 hours per day, the cycle time that is being calculated is 96 seconds per unit, and the theoretical minimum workstation is calculated as 7. Hence, as a result, the line efficiency is at 92%. Now, the next part of analysis will be explained by Ashikin.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Ashikin binti Razali and I will continue the result and analysis part. In the previous part, already mentions about the value of line efficiency, which is 92%. So, in this part, firstly, we tabulate the assembly line balancing as shown in the slide. We arrange the process according to the suitable stations. And for this project, we decided to combine process B and C into station 2 and process D and E into station 3. And then the total idle time was calculated as shown in the table, also proven by the calculations of idle time by using the equations, and we got the total idle time is 52. So, as the result, we achieved the maximum performance by lessen the number from 7 to 5 stations. And the final process are as shown in the modified precedence diagram. As we can see, the process A located in the station 1, following by the process B and C in the station 2, up until the last process in the station 7. And that's all. Thank you.
My name is Amira binti Omar and I will explain about the discussion of this project. From result and analysis, the workstation have been minimized from 9 to 7 workstations. If we have 9 workstations, employees need more movement from one station to another. So, The workstation have been reduced to 7 and it requires less movement and short time of production. For the peeling and slicing process, we have rearranged it under one station. Same goes to the frying pisang tanduk and frying pisang sabah. It is also under one station. For the output rate is 300 units and production time is 8 hours per day. 96 seconds per unit for cycle time has been obtained. From this data, the efficiency achieved 92%, which is good for productivity. Next, from table 4.3, which is tabulation assembly line balancing table, the ideal time is 52 seconds. In a nutshell, the ideal time could also be reduced as the number of workstations is minimized. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Hidayah binti Abdullah. My matrix number is DD190023. As a conclusion, throughout this case study, the objectives which are to propose a way to improve the current layout of the facility and to improve line efficiency throughout the use of line balancing were achieved. Students are also able to identify the problems that occurs during the process of making banana chips at Perniagaan Kerepek Kassah. The number of workstations had been minimized from 9 to 7 workstations. Line balancing method were applied in order to improve the productivity of banana chips production. By increasing the efficiency of their production lines, businesses may decrease lean manufacturing waste and generate more outcomes. In summary, line balancing is a technique for determining the most efficient way to ensure that any job proceeds smoothly. That's all from us. Thank you.